Hello, guys and girls. The program you are about to hear will be both fun and educational, but it is not a substitute for medical advice. Although we are doctors, we are not your doctors.
Hello and welcome to Travel Medicine. As always, I'm your friendly neighborhood internal medicine doc, Dr. J.
Hey all, this is Dr. Santhosh, pediatric infectious disease doc and a researcher. Existentially stressed out.
Well, come along with me, listening audience.
Yeah, go ahead.
Do your teeth have a taste,
Oh,
or
God.
or is your tongue so used to it that your teeth just taste like nothing to you?
So this has to do with two separate things. One, does tooth enamel have taste? And the other part is this. I forgot the name of the inhibition that senses go through when they're kind of saturated with a particular thing. So, as a for instance, if you smell something a lot, then your brain kind of shuts down that smell for a bit because it realizes it's a background smell, it's not important. That's why your house doesn't smell funny. Even if somebody else comes in and says, "What's that smell?" Your house just smells like your house and you don't even notice it. Uh, the question that Dr. Josh had was that if you're living with your teeth for all this time, does the taste receptors finally go, "Oh, okay, that's tooth taste. I don't need to register it to the brain anymore." It just stops. Which, by the way, I didn't think of this until just now. Do you think part of why babies cry so much when they're teething is because maybe teeth do taste awful? And the baby's
Just
teeth are coming in, and they're just going, ah.
maybe only babies truly know what teeth taste like. And
Because they've never
all
tasted teeth before. I mean, like most babies haven't tasted teeth before. I'm presuming.
How many of you just licked your teeth while listening to this? Be honest, we can't hear.
Yeah. And oh, by the way, there is going to be taste that's associated with food particles, form,
But
and
that's food particles. That's
that's
not
food
licking your
particles.
teeth. Tangentially pertinent to
Yeah.
what we're talking about
Yeah,
today.
yeah, that's true.
Only because this is an episode that we're going to focus on all the bodily fluids, or most of the bodily fluids.
Yeah.
And, I do believe I was looking at the calendar, and I think it's an alternate week, Santosh.
Oh my gosh. You know what, Josh? It is.
And I don't know if you know this, because it's only been 10 years, but
Welcome, new audience members. Yes.
on alternate weeks, we like to do a little something that we call Journal Club. Yay!
Yay! For all of you newcomers, please do rewind your, podcasting device, whatever it is. Get your Kermit arms ready up in the air. Hit play. Play that section one more time, and just wave them around.
It's time to read some journals, look at science highlights. It's time to see what folks are up to in the research world tonight. Ba-dum, bum, bum.
Dum bum bum.
Why do you always come here? I guess we'll never know.
But we've got some real cool headlines, so here we go.
Da, 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 da. So today's episode is focused on blood, sweat, tears, bodily fluids, exciting journal topics. And let's spin this very tiny, very disgusting wheel. And it turns out that our first fluid up is sweat.
Oh, okay. So I mean, the statement is usually blood, sweat, tears, but I guess we'll take kind of a little detour.
You want to start with blood? We can start with blood.
Oh, no. Let's do sweat first because I mean, this is an infectious diseases topic, and I absolutely love it. So yeah, let's go for it.
So, story number one, sweat or more accurately, a protein in sweat, may provide some protection from Lyme disease.
Yeah, with a big ol' emphasis on the may over here.
Asterisk.
Yes,
Asterisk.
absolutely.
Exclamation point. Emoji.
And, oh, by the way, in the countries of Finland and Estonia.
Before we get into the research, Santhosh, briefly, what is Lyme disease and can it truly be chronic? Stop yelling at us, audience. We can hear you.
I can hear you all the way through here, absolutely. Very simply, Lyme disease is caused by Borrelia burgdorferi, which is a little spirochetal bacteria. It's transmitted by ticks and infects lots of different mammals, but primarily humans. And the stages that we know of for sure are acute stage Lyme, when you have fevers and you have headaches and you feel a little bit almost like the flu. And then later stage Lyme, if it's not treated properly, where it can infect the heart and cause arrhythmias and carditis, or cause infection and inflammation in bones and joints and cause arthritis, and occasionally associated in scary stages with neuropathy, where you can get something like Bell's palsy, weakness of one side of the face because of inflammation of the facial nerve. Now, there is lots of controversy about, even after treatment or with treatment, etc., if this spirochete can stay in the human body for a long time and cause chronic infection. The data so far says no, absolutely not. But it can leave a person kind of tired and weak, not from the infection, but from the post infectious inflammatory response. We've been trying to get diagnostics on Lyme for a long time because all we have right now are serological or antibody studies, which is not great. Treatment is very, very good, but there are a handful of folks who are left with this kind of tired post-infectious fatigue, and it is very, very difficult to deal with, but it's not due to infection. And now I think to talk about the study, which you're going to introduce us to, we're hoping to find some reasons for why some people are especially vulnerable to contracting Lyme when they get bit by a tick versus others who are perhaps a little bit more resistant.
Researchers at MIT and the University of Helsinki have
Yay!
discovered that human sweat contains a protein that may provide some protection against Lyme disease. Researchers Tal and Olila were postdocs at Stanford University, began this a few years ago, mostly to find genetic markers of susceptibility to Lyme disease. So the research we ended up with was not where the research began.
They're working a little bit backwards. They're looking through databases of people who have contracted Lyme disease, and then those people who have genetic information shared on two particular servers. One is a Finnish data set. That's FINNISH. So it's called the FinGen project. Or over in Estonia, where they keep a biobank, using the clinical data and matching it up with the genetic data from the patients who had voluntarily given their genetic information to these biobanks.
So this Finnish data set had a total of about 410,000 people with detailed information on their genomes and medical histories. Of those 41,000, about 7,000 had been confirmed and diagnosed with Lyme disease. So they could start looking at genetic variants that are more frequently found in people who have Lyme versus those who hadn't. Now, the first couple they already knew about, had been discovered before. Nothing terribly exciting going on there. But the third hit
Yeah. Yeah,
was
that was a
technically it's
weird one.
called a secretoglobin, but I like it's a secret oglobin.
Yeah. Well, the proper, the root of the word that we're talking about is secrete, meaning it's a globular or protein that is secreted. But yeah, I think it's kind of fun because this protein was a secret until it was found.
So
That
this
this was
secret globin,
Yeah, it was a secret globin. As far as Lyme was concerned, it was a secret globin.
SCGB1D2.
Ugh, scientists with your naming conventions. Come
Right?
on, people.
At least we got secret globin. So
Yeah.
they're a family of proteins found in tissues that line the lungs, among some other organs, where they have a role in immune response to infection. And this particular one is produced primarily by cells in the sweat glands.
Yeah, so there's a whole family of these types of genes, and you find them expressed in barrier organs. So, along your digestive tract, your upper airway, your lower airway, and your skin. And each of them forms some sort of a almost like a protein mesh to help protect whatever organ they're associated with. But these are a family of proteins that we have evolved to basically keep any tissue that interfaces with the outside world safe from that outside world as much as possible.
So, the normal version of this protein, when chucked in a petri dish, significantly inhibited the growth of Borrelia burgdorferi.
Oh yeah.
However, when
Okay.
they exposed the bacteria to a mutated version of the same protein, it took twice as much to suppress bacterial growth. So that shows that this particular variant does, in fact, have a protective effect because if it's changed even a little, it takes a lot more protein to achieve the same results.
Yeah, so the researchers here found mutations which caused what's called a missense amino acid substitution. So basically the change in the genetic code in a given person for that version of that gene that individual had would change something like a phenylalanine to a leucine. And this would change the shape of the protein and thus whichever function it had. Now, this doesn't mean it's dysfunctional or useless in any way. It just means that very specifically, when they tried to relate it to Borrelia burgdorferi in a petri dish, it didn't have that inhibitory effect that they were expecting.
So they published these initial findings on a preprint server, something like bioRxiv. Don't correct me.
No, okay, fine.
And and once they did, a whole other group of researchers in Estonia, of all places, managed to replicate the results of this study using a completely different biobank, the Estonian biobank. And this included data from about 210,000 people, 18,000 of which had Lyme disease, and all of these findings from the two different studies were ultimately combined together into the final study in Nature and Communications.
You might say that the Estonians finished what the Finnish started.
What the finished started?
Oh, it makes I love that we can make European puns about this. Yeah. But it actually I love this because of the power of what happens when you have a really well-run social medical system and you have the ability for people to volunteer their information like this. The beautiful thing is these are well-funded public health systems that are also going to be very well protected, encrypted, and the data is not going to be like all over the place the way it is for like A23andMe or ancestry.com. And then it is very, very useful for researchers like this who do have to pass certain bars in order to be able to access this and also make a ton of promises never to abuse this data. But the power of having these databases means that you can execute these types of searches. I mean, who the hell would have thought that a secret globin in your sweat would have a function in slowing the progress of Lyme disease? It makes some sense because in order for Lyme to transmit, a tick has to, bite into the skin. It has to put that little proboscis into the dermal layers. And then, Lyme has to make its way through while the tick is attached and sucking blood from the tick's tummy to the mouth parts and then into the host, the human. So if you had some sort of chemical or protein on the skin itself that prohibited microbes to invade like this, then you're going to slow down the possibility of infection, even if the infected tick is biting you.
So
So
ultimately, they hope to, even though they don't know why it inhibits bacterial growth or why the
yeah.
variant is less effective, we do see that the variant causes a shift from the amino acid proline to leucine. They hope to ultimately harness what they learn to create skin creams that could help prevent the disease or even treat infections that don't respond to antibiotics. But it's important to keep in mind here that this does not mean you are immune, that heavy sweaters can go skipping freely through the forests nude. People who have this protective version can still get Lyme disease.
Yeah.
And part of this is, are you actively sweating when you're bitten by a tick
Yeah, yeah.
or not?
Remember, a lot of the time, Lyme is transmitted by ticks in kind of middle months. So in the northern hemisphere, August and September, where it still might be hot, but it may not be. It may be getting cooler, and you're hiking, and you decided not to, wear proper protection, long sleeves, long pants, etc., and repellents, and you're not going to be sweating. That bugger is going to sneak in. Now, Josh, there was one cool extra step that was done in the Nature Communications paper, which I absolutely love. They went ahead and incubated experimental strains of Borrelia with SCGB1D2 and compared it to controls, and then actually infected mice, which are natural hosts for Borrelia, and then saw how quickly the Lyme proliferated versus if you just infected it with Lyme alone or Lyme with a different secret globulin or secretoglobin.
Like a
And
coconut, Lyme with
like
a
a
coconut.
Lyme with a coconut. And it turns out that if you incubate the Borrelia with SCGB1D2 for a little while in the petri dish, and then you use that for infection versus a Lyme agent alone, you actually get a lot less proliferation of bacteria, and the mice, live a lot better. So it was a cool little extra preclinical step. Still not ready for prime time, but I like that extra step that the researchers took. You put the lime with the secret globin, stir it all up.
Moving on to our next bodily fluid. Santosh, you were pretty hung up on blood, so we can move to that one.
Well, I wasn't hung up on blood. I was just following the order of the idiom was the thing. As
When you think of getting tested for a disease, traditionally you think of nasal swabs, urine tests, blood draws.
needles,
hmm Um, but earlier this year, the FDA, for the very first time, approved a health test based on menstrual blood.
Oh, nice. So blood that you can collect without having to, poke a giant hole in someone.
Yeah, blood that collects you.
And hopefully blood that contains useful information.
So yeah, we're going to get into that because this particular one I'm going to group together several different studies. So
Okay.
this particular test that we're talking about that was approved by the FDA is an at-home test that detects a biomarker for diabetes, which is an alternative to the typical blood draws required to diagnose it.
Oh,
So
okay.
the earliest version of this study was in 2019, and it compared samples of menstrual blood with blood that just circulates through the body from 20 women over 2 months. And that team found that menstrual blood could reliably estimate levels of several different biomarkers, including diabetes, inflammation, as well as reproductive hormones. And they then postulated that it could be an alternative source for monitoring health and diagnostics.
So I hope that everyone does take a little while after you're done with our podcast, or even right now while you're listening to us, to please go to the link that Dr. Josh provided in the show notes for this 2019 paper by Nasseri, Lerma, and Blumenthal in Sci Fortune. I love that one. In the Journal of Clinical and Laboratory Medicine. This is a really, really beautiful correlative study. It is a small population, but what I want people to really look at is the best fit line that goes through the correlation between like a menstrual blood and systemic blood for each marker that they're looking at. Josh, this is one of the most tightly correlated lines that I have ever seen in my entire life. There is next to no difference at all when comparing, one to the other, menstrual blood to systemic blood, for cholesterol, creatine, hemoglobin A1C. I think the only one that was not fully one-to-one was follicle stimulating hormone, which makes a ton of sense, but there was still a linear correlation that you could calculate very easily.
So if your cholesterol is high in your normal blood, it would also be high in your menstruation. If you want to check more often than however you follow up with your PCP for blood tests, or if you're scared of needles,
Mhm.
this may end up being an alternative. Now, this particular test, again, is just an A1C, very easily done with a regular blood test. It's not something that's checked all the time. And there are faster ways of doing this because the QPAD test kit has two specially designed pads with removable collection strips. So one would collect a sample during a menstrual cycle, then both strips are mailed to a certified laboratory for testing. Results arrive through an app or email, all of which sounds very nice and high tech. But when you think about the fact that if you go to your doctor's office, it's about a 2-second blood test, you get the results at the end of the day, and it doesn't necessarily cost $49, which is what this test does. So it might not be affordable for everyone. Now, it doesn't require a prescription, but insurance doesn't pay for it. So there's a lot of mixed benefits here. The technology, the idea behind it itself is wonderful. Should you go out and pay $50 to wait a week for results of a test that could be accomplished within 5 minutes in your doctor's office? Eh, debatable.
Yeah. I think in this particular case, it was a really cool proof of concept, meaning that we were looking, or I should say, the investigators at Stanford were looking for a, the ability to test a quantity in menstrual blood where the measurement is very well known and understood in systemic blood. So basically, you're able to run that correlation, market the test, send it out, and do post market analysis to see, if your results keep up just as how they are. My curiosity piqued when I looked into the study and I saw that they were looking at many different other markers of, metabolic disease, cholesterol, triglycerides, LDL. And if you could do a whole panel off of this blood, that would be absolutely amazing. But I don't think they were quite there by the time of publication in 2019.
Now, that's one of the earliest ones that's just been approved, but it is not the only group of researchers who have thought that menstrual blood may have some additional benefits. There's another study from 2013 where a researcher named Metz and her team launched the Research Outsmarts Endometriosis trial, or the ROSE trial.
Oh, hey, all right. Way to name something, scientists. I like it.
Initially, scientists provided menstrual cups to 22 women, about a third of who had previously been diagnosed with endometriosis, which is not a traditional way of diagnosing or studying. And endometriosis is, it often goes ignored or dismissed for many years before women can get a reliable diagnosis.
Yeah, oftentimes there can be pretty large variances in how the pain of endometriosis shows up, how a person experiences it or how they describe it, and how it correlates with the menstrual cycle, because sometimes it can be, spot on where, a woman will have pelvic pain during the cycle, but it can also be off cycle, etc. And Josh, I'm kind of sad to say that, especially because this is mostly a clinical diagnosis, and difficult for a lot of people to pin down in an objective way, that there are a lot of times when a woman's pleas for help just go ignored. There is another subset of women where you actually do diagnose it properly. You try all of the kind of mitigating, measures that you can, medications, sometimes surgery, and it doesn't work.
So, in order to provide a more reliable and rapid way of diagnosing, this study was carried out where scientists analyzed specific cells in menstrual blood that was collected on the heaviest days. They discovered several different genes that are regulated differently when comparing between women with and without endometriosis. So, no smoking gun, as it were, but a couple additional clues that may ultimately lead to a diagnostic test that would allow this to be determined faster and without invasive surgery, biopsies, or prolonged uh, diagnostic periods. At this point, still a fairly understudied bodily fluid in terms of what we do with it, but there are many, many researchers out there carrying out a wide range of different studies to see what new information we may be able to take for this part of the population. So it's pretty exciting.
I love it. Anything where you really engage with a subset of humanity with a disease that's not well kind of funded in terms of its research and recognition.
Let's move on to our next study. So we've covered sweat, we've covered blood. I know what you're thinking, that the next and third part of that triad is tears, but that's not where we're going. We're going a little bit lower.
We'll there might be some tears for our final fluid, but in the meanwhile,
In the meantime, we are going to look at urine. You're in what? You're in trouble because we
yeah,
have
because
potentially developed a vaccine for urinary tract infections.
woo. Now
Just,
this one,
urinary tract infections in general.
yeah. It's a tough one, man. This is a difficult one for sure, because urinary tract infections don't occur frequently in everybody, but it does happen from time to time that a person will be vulnerable. They'll be perfectly normal, no anatomical differences or anything like this. But by and large, women, they'll have just the wrong set of circumstances where they get recurrent or frequent urinary tract infections despite their best efforts. And this is what this type of vaccine is aimed at.
The initial results from the very first long term follow up study on the MV140 vaccine were just recently presented at the European Association of Urology, where European is not just a location, but also a mission. Because European easier,
Right.
European without difficulty,
Without difficulty, yeah. For those of
contains.
you in Europe who haven't, just thrown down your listening device in disgust, thank you for sticking with us.
They knew what they signed up for.
I'm just imagining some, poor, wonderful French person who is like given a recommendation of this podcast over here. It's just like, oh, I was told it was informational and, a little ha ha funny.
So the vaccine contains inactivated bacteria of the four most common species that cause recurrent UTIs, and that's our good old pal Escherichia coli,
Mhm.
along with its bosom buddies Klebsiella pneumonia, Enterococcus faecalis, and Proteus vulgaris.
Yeah. All of these are found predominantly in the intestinal tract. And we're fairly sure that most of the time when a person gets a urinary tract infection, you have what's called retrograde infection, where there's some small amount of bacteria that's hanging around the groin, and probably native to the lower gastrointestinal tract and your fecal microbiota. And it just managed to latch hold of the end of the urethra and climb on in. And then if the flow of urine is not basically steady, if there's any type of obstruction or holding, or sometimes there can be some inflammation at the end of the urethra that doesn't allow you to empty your bladder all the way, then the bacteria love to proliferate in that yummy, tasty urine because it is full of all the nutrients that it needs to grow.
And we now
Hence
have
a
you on
UTI.
record saying yummy, tasty urine.
Oh, God damn it.
This study was carried out on 77 women, all of who had experienced a minimum of 3 or more episodes of UTIs in the preceding year. The majority of recurrences were in postmenopausal women, and of the 77 they recruited, 75 completed the treatment. Of those 75, 59 of them, or 78%, had no UTIs in the follow up period.
Ooh, that is a hell of a success. To go from 1 to 3 UTIs in the previous 12 months, and presumably the idea is that that's not the only history of UTI that these women have. And then you go forward and you go to nil.
You say vaccine, and I'm going to bet that Santhosh, most of our home listeners are thinking, okay, you go in, you get a shot, maybe a couple shots, and you're done, and no more UTIs, and Bob's your uncle. Not so.
Yeah.
This is administered in 2 sprays of a pineapple flavored liquid under the tongue every day for 3 months.
How did they pick?
I say pineapple because it was specifically mentioned.
Well, I know, but I'm not saying you. I'm saying the researchers. He's going around. Doctors Yang and Foley, if you could please, get back to us and let us know why pineapple. I mean, but I have no objection per se. Pineapple is a delicious flavor. So yeah, it's essentially they're actually using what's called a whole cell approach. So not a portion of the protein or toxin or anything like this. You're just taking the entire bacteria and inactivating it so it can't replicate, and then sending it in.
So the original trial, because remember, the one we just talked about was the follow-up study, which was amazing. 80% with no UTIs during follow-up. The original trial involved 89 patients, 72 women, 17 men, who got the vaccine from the Urology Partnership, and they published the first interim results in 2017 and are presenting the new ones at the European Association of Urology in Paris. And in both cases, the most recent results indicate that the average infection free period across the full cohort was 54.7 months, or 4.5 years. A little bit longer for women, about 56.7 months for women versus 44 months for men. So, yes, you do have to take this vaccine for 3 months, but then it prevents you from getting recurrent UTIs for almost 5 years. I'd say that's a pretty decent trade-off.
Yeah, I have to say on the flip side of this, which is much more impressive is that the adverse reaction rate was pretty low. In the smaller cohort that you talked about, Josh, the 77 women, there was one person who experienced an adverse reaction to Euroimmune, which is the name of the vaccine is Euroimmune. Josh,
You're immune.
you're yeah, there you go. The woman who had an issue, an adverse reaction, had a history of allergic reaction to multiple antibiotics, and had underlying kidney disease and I think multiple sclerosis as well. And so she took the vaccine and then got a bad rash after 2 days of the treatment, but it went away after she stopped the therapy. But that type of very small adverse reaction profile, even, with a small cohort like this, is absolutely fantastic. That one person had to discontinue treatment, but as you can see, she had a lot of comorbidities. I love this approach because these are native bacteria. So technically speaking, we should have a immunological kind of equilibrium with them, meaning that, if they have a tendency to come in and cause UTIs, there's not much you can do to encourage the immune system to recognize it because it's part of your microbiome anyway. If you don't have it, then, you're kind of at peace with it. But they were able to evoke enough of a protective immune response, presumably, where the epithelium essentially of the urethra of the bladder was able to stop these particular bacteria from climbing on up and establishing infection in that tasty urine.
That's just listen after every episode now. That clip will simply be included.
Yeah. So this is a form of immunization known as immunomodulation, meaning that you don't want to create an immunity such that like your body wipes out all of the E. coli from your gut. That you certainly don't want that, because a lot of the E. coli that's there as part of your microbiome is helpful. Same with the Klebsiella, Enterococcus, and Proteus to some degree. You want to basically change the way that parts of your body deal with E. coli and Klebsiella and the others when they get in the wrong spot in your body. So the idea is fantastic. I'm so glad it worked out well. I genuinely hope that this advances and becomes more widely available.
Oh, so imagine, you go to the doctor, you get your flu shot, your pneumonia shot, your UTI vaccine. We are adding things, and I commend the choice of pineapple. We need more tropical flavored vaccines.
Yeah. It was really smart, right? Like they didn't have to. This isn't a, children's vaccine. But they were like, no, people like to taste yummy things no matter what your age it is. Let's make it pineapple.
People deserve citrus. That's so. I believe I promised you tears.
Oh,
And
yes. Oh, I forgot. The urine made me forget about I'm sorry.
and that brings us to our last study. Now, interestingly, I first came across this in the Journal of Archaeology, but I was too excited about that study and determined that I was going to find a way to tie it to medicine. So I'm going to give you a little background and then we'll talk about both studies. And I'm going to start by asking you about everybody's favorite Japanese condiment, wasabi.
Wasabi. Sorry.
Specifically, wasabi japonica. Uh, Now, most of what you are thinking of as wasabi is not true wasabi. It's horseradish dyed green.
Yes. So this may end up being a problem if we find that wasabi is particularly potent in the way that we're about to discuss, because you can't substitute the weak stuff or the fake stuff. If indeed, we find an effect in this. We're about to talk about it right now. You need the real stuff, which is rare.
So what we are talking about is wasabi japonica, a green condiment native to Japan from the root of the wasabi
Wuzap.
plant,
Sorry.
closely related to cabbage, mustard, and it has to be grated kind of at the table and almost immediately begins losing its pungency afterwards. So it's not what you're seeing sitting around in your supermarket every day. But isothiocyanates found in wasabi have been
Mm.
shown to inhibit the growth of bacteria including Salmonella and Streptococcus, which is
Oh.
because it targets specific enzymes and proteins involved in bacterial replication that prevents them from functioning properly and slows down their ability to multiply and spread. So this tells us right off the bat that it's got some antibiotic properties particularly useful in food preservation,
Oh,
which
very, very nice.
which in a country that consumes a not insignificant portion of its food raw, you can imagine might be helpful.
Oh, absolutely. We are talking about specifically these two bacteria, by the way, because salmonellas are actually the number one cause of bacterial gastroenteritis here in the United States. And they're very, very good at hiding out and hanging out. And, you know, the food doesn't necessarily have to spoil or anything like that. But if there is oral fecal contamination or fecal oral contamination, meaning that the person who prepared the food didn't wash their hands properly, it doesn't have to be the typhoid strain. It can be, in fact, very often here in the United States, way more often than not, it's the non-typhoidal strain. But, upset stomach, diarrhea, and then if you're immunocompromised, you can be in real trouble, or if you're very young or pregnant. And then Staph aureus has another cruel type of a thing. It can sometimes make an enterotoxin. And in this particular case, you don't even need the bacteria to be there. The toxin is fairly stable. If you allow the food to spoil in such a way that the staph is in there and it secretes this toxin, you can even cook it to a fair extent and the toxin won't be inactivated. And that's how you get the classic food poisoning, where you eat something and then you have vomiting straight away, like a couple of hours later, but no diarrhea.
Now, most of these studies showed that it is really more of a bacteriostatic rather than a bactericidal. So it cannot completely eliminate bacteria, but it can stop it from growing and multiplying to the point where it can cause an infection or allow bacteria to grow to the point beyond which your immune system can handle it.
Yeah. You basically, Josh, we've talked about this before. The dose makes the poison, right? Many, many things in an appropriate dose, even things that you wouldn't think of as quote unquote poisonous, can be a poison. And the same is true for a bacterial infection or an enterotoxin that staph produces. If you're able to suppress the proliferation of the bacteria to a level below which it is ineffectual, then you can eat that bacteria and you won't get sick.
Now, it doesn't take a lot. The AITC at 500 micrograms per milliliter
Hmm.
was bactericidal against pathogens not only such as Salmonella and Strep, but also Staph aureus and one of our more famous bacteria, E. coli O157H7.
Is a strain of E. coli that has cleverly, in order to protect itself, actually picked up a Shiga like toxin, a toxin similar to the one that Shigella makes. And this is one that not only can cause you to have dysentery, like bloody diarrhea, if you were to become sick with this bacteria, but in children, it has a wretched side effect of inducing an inflammatory immune phenomenon after the infection is over, which causes hemolysis or breakage of red blood cells, thrombocytopenia or lowered platelets, and kidney failure, which more often than not can be reversed just with time, but other times can lead to complete kidney shutdown and can be fatal. So we've actually bred this bacteria out, Josh, by feeding our cattle antibiotics
I
and
was about
kind
to
of
say wasabi.
no, antibiotics, and encourage the evolution of this particular bacteria. And, we think about it oftentimes in contamination of green leafy vegetables because the cow poops. The poop runs off during a rainstorm or something like that into, the fields where spinach or lettuce or something like that's growing. And then a person, unfortunately, if they don't clean that material off, that food very, very well before eating it and cooking it well, can get really sick with this
So
bacteria.
at
So
500 micrograms per milliliter, you start killing off these different bacteria, but at 1,000 micrograms per milliliter, which again, not a lot in the grand scheme of things, you
mm,
actually more effectively eliminate E. coli even faster than Staph aureus. So this has potential to effectively really control these infections in foods. And again, should you start chugging or chucking down huge clumps of wasabi to fight off infections? Unlikely to be practical, but in terms of preventing foodborne infections, this is a really great natural preservative for a select area. So, something that the food industry may want to take more notice of. Now, the way I first came across the idea that wasabi had anti infectious properties, and I specifically say infectious rather than bacterial, is because it turns out you can also use wasabi to preserve and clean papyrus.
oh, some of your favorite. Are we going? Do we need to take the Wayback Machine or?
No, no, we just can, take it down the street to your local research lab where folks who are studying these ancient Egyptian scrolls. Now, for those of you who are unaware, papyrus is plant based, which
Mm,
means that these ancient records are susceptible to plant based infections like fungi. You
yes.
can't really use a lot of corrosive chemicals on them because they will fall apart. So, how do you keep your source materials, such as the Ebers papyrus, the Kahun papyrus, from getting infected and deteriorating and losing all that knowledge? Well, you can take a little bowl of wasabi and just place it next to the papyrus. You don't even have to rub it on, which is good because that means, again, you're avoiding the oils from your fingertips or particles from the food. But the aroma, the vapors given off by natural wasabi can actually kill fungal infections that the papyri are susceptible to. And that was
Yeah.
the original study I found. Has nothing to do with medicine, unless I guess you're a papyrus.
Oh no, it's preserving the Eborus Papyrus, which is
Hmm.
a medical document. So absolutely, it does, Josh.
Um, but I thought that was really neat.
It's fantastic. All of this because the allyl isothiocyanate is a little bit volatile. So that's why you can either obtain a vapor or you can just leave the wasabi in the same chamber as where you're keeping your papyrus in a kind of a closed box. And it works really well. The the properties of allyl isothiocyanate are absolutely fantastic. You do find them in a few other foods that are pungent, mustard, radish, horseradish. Wasabi contains it in kind of the most amounts, which is why wasabi is a powerful, Josh, lacrimator or a tear causing agent. So yeah, it'll preserve against fungus. It will have some activity against bacteria. You can also use it as a spray to repel things like fire ants. Because that'll sting the fire ants and keep them away from you if you're in a place where you want to keep pests away. So it's a fun, wonderful, pungent little chemical as long as it doesn't make you cry.
So there you go. We kept it mostly above the belt and covered a whole bunch of bodily fluids and some pretty fascinating ways that they are being utilized or taken advantage of.
Yeah. Although I would advocate for, you should go below the belt from time to time. There's fascinating stuff down there.
Yeah, what you do on your weekends is up to you. I'm not here to judge.
I'm just kind of digging a hole for myself, aren't I? Just you have, but like just this episode alone, blackmail stuff for days.
All I'm saying is I'm not the one who advocated for delicious urine
I'm
on air
advocating.
on air twice. But you do you.
I will. Thank you.
so, so that's it for this week. As always, we love to hear your comments, questions, and feedback. If you'd like to support us spiritually, emotionally, or financially, links to do that are in the show notes, along with links for further reading. Like, subscribe, recommend, and that way we can tell you when we are going to be doing more live shows. We got at least one or two of those, I think, coming up this year. More details on that forthcoming. Our theme music is composed by Rachel Leisure. And the show is produced by me with a lot of help from Dr. Santhosh and friends. And until next time, as always, keep a song in your heart, soap on your hands, a shot in your arm, your fluids in science labs, and a spin on your globe. And once you've done all those things, pick somewhere that fascinates you. And happy travels.
Bye, everybody.